Go. Okay, the first way, which I'm pretty sure everybody has taken into consideration before, is this thing called substitution. Who's heard of this before? Substitution. Okay, this is a very fancy way of solving a system of linear equations. So let me give you an example. Let's say we have this. Let's do 3x plus 4y is equal to 12. And let me give you 2x plus y is equal to 10. There is something that's very nice about using the method of substitution for this type. Anybody see what it is? What's nice about it, Jake? What do you see, dude?
Well, the y is alone. So
Yeah, the y variable is already sitting by itself. That lends itself to substitution. So if you are looking at a system and you notice that one of the variables is already by itself, substitution might be a good way to go. So what we're going to do is we can say, well, then y must be equal to negative 2x plus 10 if I isolate y. Do you guys agree with that? Okay, good. The cool thing is you take that information and you drop it right there in the other equation. So you're basically substituting one for the other, just like a person in a football game, right? One comes in, one goes out. Substitution. We're putting one in for the other. So then here's what we get. We get 3x plus 4, and instead of y, we're going to substitute negative 2x plus 10. And that's still going to equal 12. So the rest is just algebra. 3x. This is going to be minus 8x, and this is going to be plus 40 is now equal to 12. Am I doing that right?
yes.
All right, cool. Moving up. So this looks like negative 5x is now equal to, if I had 12 minus 40, negative 28. Let's divide by negative 5. Let's divide by negative 5. So it looks like x is now 28 fifths. And you know what? That's okay. We can leave our number at 28 fifths. Okay? There's nothing wrong with 28 fifths. But are we done with the problem? No, because we then take our x value and look, we can substitute it right there. No, it's easy. So we're going to have negative 2 times 28 fifths and then plus 10. Oh, this is easy. So let's see here. If I double 28, I get what? 56? So I get negative 56 fifths. Now 10 in terms of 5 would be 50 fifths. That's the number 10, right? Not 2. Okay? So then I'm getting a grand total of negative 6 fifths. So the solution to my system would be the x value of 28 fifths and the y value of negative 6 fifths. Whoops, that should be a 5. Okay? Now check this out. I actually did this one, I think right here. And look, there it is. 28 fifths and negative 6 fifths. And we could see exactly the little green dot is the solution here. Is this an inconsistent or a consistent system? It's a consistent, independent system. That would be the right answer, okay? All right, cool. Okay, you and somebody close to you solve that. Tell me what you get. When you solve this, you should get negative 5 halves and 5 halves, or negative 2.5 comma 2.5. Leave it as a fraction if it's an easy fraction. Either representation is fine with me. All right, the third way after graphing and substitution is this method called elimination, which is highly popular amongst the kids these days. And the way that I see it is I see this in columns, okay? I see like the yellow column, and then I kind of see the blue column here, and then I kind of see the green column over here. So I want you to think about lining up your x's, lining up your y's, lining up your numbers, okay? If you do that, you should be able to see something. And now this is the easy example. This is example A. Example B is a little bit more challenging. But if you look vertically, why is the elimination method so nice? Jake, what do you see, dude?
The x's cancel each other out.
Exactly. So you're left with this. 5y is equal to 25. Holy cow. Y must be 5. Look how fast we did that one. Now this is the easy example. Well, that's okay. But yeah. But then, of course, we substitute back in for the x and, whoops, sorry, for the y, and get the x. Right? So we get 4x is equal to negative 1. So then x would be negative 1/4. And you can check the algebra later. That's the easy one. The more challenging one would be this one. This is the one that I kind of want to focus on, right? The more challenging one would be this. 3x plus 7y is equal to 15, and 5x plus 2y is equal to negative 4. So first of all, what makes this more challenging? Yeah, Rachel, what do you think? They're not, yeah, no x value nor y value is the same or opposite sign. So we actually have to do something. We have to make equivalent equations. Exactly. So what do you want to multiply the first one by?
-5.
Multiply both sides by a 5. And then let's multiply both sides by a negative 3. Why negative?
Because they're gonna cancel each other out.
There you go. Okay. So then, ladies and gentlemen, okay, my first operation here, if I did 5 times the first row, I would get 15x plus 35y equals, let's see here, what's 5 15s? 75. Very good. The second equation would give me a negative 15x. That's very nice. Minus 6y equals positive 12. Now we've set ourselves up nicely for the x values to be eliminated, leaving us with 29y is equal to 87 divided by 29. Actually, it's a really nice number because it's 3. Okay, so let me move over here. So y is a value of 3. Are we done? No, we go right back here. We plug in a y there. X would be what? Did you guys figure it out?
X equals -2.
Negative 2?
I got -2.
I am getting... I got negative 2 out of this, okay? Okay. Okay, here's the last box of this lesson. It's, I want to know what you think. I want you and somebody else right next to you. Try and solve both of these either way you can. And I want to know what you think. We're going to spend the last 8 minutes of class talking about it. Alright, so when you did this, you should have come up with something interesting for the first one. What did you guys realize for the first one here? You get 0 equals 0, and then I'm hearing this thing about all real numbers. But let's go a little bit deeper here. Nick, what do you think, my man?
It's not all real numbers, but there's some solutions like if x is 1 and y is -2.
Yeah, okay, so you're on the right track. If I were to graph this system, what would you expect to see? You would see that these are exactly the same line, right? One's on top of the other. So you're getting a true statement here, and that's going to represent a consistent, what type of system? Dependent system, okay? Now, what about this one over here?
Inconsistent.
What do you get?
You get 0 equals 16.
You get 0 equals 16 or something?
Yeah.
That's not true, right? 0 doesn't equal 16. So therefore, you would have parallel lines, right? So you would have an inconsistent system right away to begin with. So you don't even have to graph. If you end up with a true statement, you'll know what the answer is. If you end up with a false statement, you will know what you're dealing with right away. Okay? That ends 3.2.